In this example, we're going to determine the equation of a sinusoidal curve shown below. Now, the first thing we have to do is determine whether we're going to use positive sine x or negative sine x or positive cos x or negative cos x as our parent function. And since this curve begins on the axis of symmetry and ends on the axis of symmetry and goes up to start, we're going to say that this is a positive sine x curve. So our parent function here is going to be y equals sine x. Okay? Now, our phase shift is one square to the left. Each square is 20 degrees as shown by the scale on the x-axis. So our d value will be negative 20 degrees. Our period is the horizontal distance, horizontal length of one cycle. We don't count from the y-axis necessarily. We count from the beginning of a cycle to the end. Well, that's 12 squares wide. And so that means that on first glance, you might be tempted to say the period is 12. But remember, every one of those squares has an index of 20 degrees. So the period is really 12 times 20 degrees, which is 240 degrees. All right, well, we know in this course we can assume that the k value is positive. That has to do with the way we choose our parent functions and our phase shift. So anyways, k is positive. And since we're in degrees, because the scale is in degrees, we'll say k is equal to 360 degrees divided by 240 degrees. The degree symbols cancel out. We got 360 over 240, which is 3 over 2. Now the amplitude is, the axis of symmetry is right here at y equals 4. Now, some of you might be able to, y equals negative 4. Some of you might be able to spot that just by observation, and you can say that c is equal to negative 4. If you don't like doing it, though, just by observation, you can use a formula. And the formula is that the c value is going to be equal to the maximum y value plus the minimum y value, all divided by 2. And when we do that calculation, we end up with a c value of negative 4. And finally, the amplitude. Well, the amplitude is the vertical distance above or below the axis of symmetry. So in this case, we can see by observation that it's 3, but some of you might prefer a formula. So what we can do is we can say it's the maximum y value minus the minimum y value all over 2. Negative 1 minus negative 7 all over 2 is equal to 3. So the amplitude is 3. Now, what does that make the a value? Well, since we're using positive sine x as our parent function, that means that we can say not just that the amplitude is 3, but we can say a equals 3. And so now we can state the equation of our curve. Y equals a sine k x minus d, so it's plus 20 degrees, plus c, which is minus 4. And there's the equation of that curve.